In part A of question 1, I need to solve the simultaneous equations in order to find the points of intersection. You can see that I obtain a quadratic in x, which actually factorises, meaning I obtain the values x equals minus 5 or x equals 2. To obtain the following values of y, I needed to substitute into either of the equations, and I chose the equation of the line just because it's a slightly easier substitution. And I find the values of y to be 5 or 26. And so that means the points C and D are minus 5, 5 and 2, 26 respectively. I can use the Casio Graphical Calculator to confirm this. If I choose option 5 from the menu, I'm taken to the graph function menu, and I'll first key in the equation of the line, which was 3x plus 20, and I select execute, and I'll now input the equation of the curve, which was over here, y equals x squared plus 6x plus 10. And select execute. Okay, let's draw these, and I'll choose F6 to do that. Now you can see that most of the curve and the line are in the top left corner, and so I certainly need to change the scale. I can see that I have a lot of area down here not being used, and so I certainly don't need such a low negative value for the y-axis. So if I select V window, and here I'm going to change the x maximum to 5, and if I scroll down to y, I'll now change that to simply minus 5, and the maximum, let's try 30, and I select execute, and one more time, and now when I select F6 and draw, okay, so that's clearer, but certainly there's a point of intersection over here that's not easy for me to see. So I need to change the x-axis range so that I can capture more of the negative numbers. So if I go back to V window and change the x minimum to minus 10 and select execute, and one more time. Now when I press F6, it's clearer to see the parabola and the straight line. And what I want to do for part A is confirm that I got the points C and D correctly. So I select G-solve, which was F5, and I'm interested in the points of intersection, which you can see here again is F5. Immediately it gives me the first point, minus 5, 5, and as you can see that's point C. And if I scroll to the right, I get the second point of intersection, which is 2, 26, which corresponds to part D. So part A of my question looks to be correct. Now let's think about part B. I need to find the area of the shaded region enclosed between the parabola and the line. Well, using calculus, this diagram really helped me because I realised that the area underneath the line between minus 5 and 2 needs to be calculated first, before I can subtract the area under the curve between minus 5 and 2. And that's because the diagram shows me the line is above the curve when x is between minus 5 and 2. When I do use calculus, I obtain 57 1/6. So let's check that using the calculator. If I choose G-solve, and I want to scroll to the right, so I'll select F6, and I would like to integrate this. And what I'm actually interested in is not the straightforward integral of one of the two curves, but actually the area between them. So if I select F3 for intersection, it's now going to work out the area between the curve and the line, provided I put the correct parameters in. The first one is the x value of minus 5, that's the furthest to the left, And if I select execute, it now asks me for my upper limit value. And if I move to the right, my upper limit value is 2. And if I select execute, you can see it has shaded the region between the two. It's given me the lower limit of -5 and the upper limit of 2. And it's worked out the integral to be 57.16 recurring, which is exactly the same as 57 1/6. So again, this confirms that I have part B of the question correct.